Hey, hello guys, welcome to Network Beats. This is Tangadurai, and in last video we have seen about eBGP features, which is eBGP multi-hop and disable connected checks. So, in this video, I would like to do something else with the iBGP, which we have missed in previous sections. The thing is like about the AS500. Okay, so here, if this AS500 is a enterprise network, then it is good to have BGP only on the edge routers, right? What if suppose AS500 is a ISP network? Okay, an ISP network, like all the routers in the core will be running the BGP. It is not as always. It may be uh, as per the requirement. So what happens here is like I would like to run BGP on all the four routers. So that we will see how the uh, routes are getting exchanged from R5 to R4 by doing changes on R1 and R7. So by doing these changes on AS500, this is going to change the complete hierarchy of our configuration. Why? Because that means like what I mean to say, as per our current setup, R2 is having iBGP peer with R6, right? And R1 and R7 does not have any BGP config. So, and whatever is learning via BGP is being redistributed to EIGRP so that R1 and R7 can understand these routes, so that R1, R7 do not drop any packet while routing the prefixes or routing the data from one network to another. So that is what the issue that we have faced, that we have fixed in last troubleshooting video. So now what I'm going to do, I'm going to remove this pairing which I have between R2 and R6, and instead also I'll be removing AIGRP, which I no more required. And what I'm going to do, I'm going to enable BGP on router 1 and router 7. Okay, and R2 will be forming a neighborship with R1, and also it will be forming neighborship with R7. Now also R6 will be forming iBGP peering with R1 and iBGP peering with R7. Okay, and we'll see how our routes are getting exchanged, and then we'll come back and we'll discuss what will be the problem that we are facing and how to fix those. So let's get started with our configurations. So here is my terminal. Let me go to R2 and let me just type no router EIGRP 100. Okay, that's it. All my EIGRP config will be gone. And then what is R1? Same thing I have to do, right? Okay, no router EIGRP 100. And then R6 and R7. Configure terminal, no router EIGRP 100. Same for R7, no router EIGRP 100. And also I'm going to do, if you see that show run pipeline section router BGP, same for router 6. Let me see what is the config currently we have. We have neighborship with R6, which I no need anymore because we are going to change the things to understand other things which are relevant to iBGP part. So configure terminal, let me go to router BGP 500 and let me just type no neighbor 6.6.6. This clear all the configuration related to 6.6.6. All these three line will be gone if I say that now. Okay, so let's go to R6 and do the same. Router BGP 500, let me give no neighbor 2.2.2.2. Okay, so now what I have to do, so in R2 inside AS500, I'm going to use every router's loopback IP address to form my iBGP peering. Okay, so here in R2, what I'm going to do, router BGP 500, and first let me start configuring with R1 neighbor 1.1.1.1 remote AS. He's also from 500, and the same thing goes for router 7, right? 7.7.7.7. And what I have to do now is here, since I'm trying to peer to the loopback IP addresses, I have to mention here update source loopback 0, and same for the neighbor 7.7.7 update source loopback 0. So we are done with R2. Okay, I don't need any configuration to R6 now. Okay, because that is why there is a purpose for not doing it. So let's see. Okay, now in R1 router BGP 100. I'm sorry, it is 500. My bad. Okay, router BGP 500. And then I have to say that BGP router ID, right? BGP router ID 1.1.1.1, and my neighbor is 2.2.2.2. Remote AS would be same 500, and let me also put update source loopback 0, and then neighbors 6.6.6.6 remote AS 500, and neighbor update source loopback 0. Okay, I'm done with R1. So let's go to R7, configure terminal, router BGP 500, BGP router ID 7.7.7.7. Okay, then neighbor, which is 2.2.2.2, and he's from the remote AS, same, it is 500. And let me also say that update source loopback 0, and neighbor 6.6.6.6 remote AS is 500, and also let me say update source loopback 0. The problem here is now we are not seeing the neighborship is up. Okay, let us complete first for router 6 as well. Router BGP 500, neighbor who is 1.1.1.1, remote AS 500, update source loopback 0, then neighbor 7.7.7.7 remote AS 500, then update source loopback 0. That's it. So BGP config is over, but the problem is with the reachability, because I have deleted the EIGRP part. So these guys don't have the reachability within. They don't have any routes to reach these loopback IP addresses. That is why they are not forming the BGP adjacency. So in order to do that, let me quickly configure EIGRP as well. EIGRP EIGRP 100, sorry, typo, router EIGRP 100, passive, okay, it is router 2. I'm making passive interface for fast ethernet 0/0 because I don't want to send my hello packets over fast ethernet 0/0, because which is leading to AS35. Only I need to enable EIGRP on AS500, that is BGP AS500. So I don't want to send any AJP hello packet outside my AS. So all these interfaces I'll make passive interfaces for EHRP. Okay, so in router 2, what I have done, okay, and simply I have to say, okay, network 12.0 no auto summary, no auto summary, and the network I'm trying to advertise is 12.0.0.0.0.24 and network 27.0.0.0.0.0/255. I'm done with R2, and then this I can do, or basically also what I can do is like I can simply say network 0.0.0.0.0, okay, but only for the edge routers I'm more specific here just to by mentioning these prefixes, because when I say, even though it is a passive interfaces, right, which is a 25.0.0.0, and if I just go and say here under EIGRP network 0.0.0, okay, it is going to advertise all the prefixes which is available for the R2, including 25 prefix, right, which I don't want. So that is why I'm doing in this way. So here I'm done with R2, but for R1 I'm not going to do the specific routing. Router EHRP 100, I'm just going to give network 0.0.0. Here it is fine for me, no problem. Okay, and for R7, router EHRP 100, okay, and passive interface, which is gig 1/0, passive interface fast ethernet 4/1, and then I'm trying to advertise 777 and the wildcard bits, and then network 27/24, and then what else we have, it is 67. That's it. Okay, so it is done. Now we should have the reachability, and for same I have to do it for router 6. Let's quickly do that. Router EHRP 100, here passive interface fast ethernet 0/0, passive interface gig 3/0. Okay, fine, and then network 6.6.6.6, and the network 16.255, and the network 67/24. So that's it. So now it is not only about the EHRP, but also we should see the BGP adjacency should come up, that we have already seen that, but still we'll verify that. So from router 2, show IP BGP summary, I got peer with router 1 and router 7 from router 2, right? I got okay from router 2, I got peering with router 1 and router 7, which is fine for me. And then from router 1, which is show IP BGP summary, I got two neighbors, which is R2 and R6, right? On R2 and R6. That is good. So from R6, show IP BGP summary. Again, I should see two neighbors, which is one with R1 and R7. And from R7, show IP BGP summary. I see peering with router 2 and router 6. Okay, that's good. So far it is good, but the problem here is now whether we are able to see the prefixes which are coming from R5 to R4 or vice versa. because whatever the prefix is being advertised from R5, which is going via AS500 to reach R4, it is not going to work in this fashion now. Why? Because uh, there is some behavior which is stopping us to advertise these prefixes of front and back. What it is, let's see, because there is a rule, right? uh, BGP split horizon. What does it say, right? Okay. Now R5 will be advertising its prefixes to R2, right? So when R2 is advertising that prefix to any of its iBGP peer, okay, this iBGP peer is not allowed to advertise that to any of its another iBGP peer. So this is not allowed as per the split horizon rule, because split horizon is stopping that in order to prevent the loop. Okay, so this is a loop prevention mechanism that you can say inside the iBGP. Okay, let me just repeat the process. Okay, so pay attention. So when okay, when R5 is advertising its prefixes to R2, okay, this R2 will be receiving those prefixes and it will be advertising it to the iBGP peer R1 and R7. Okay, when any of the prefixes are learned from one iBGP peer is not allowed to advertise to another iBGP peer. That means R1 is iBGP peer for R2. So it has received this particular route update. Now R1 is not allowed to send that update to another iBGP peer, which is R6. So there is no way R6 is going to know about 5.5.5.5. Okay. In similar way, if you see here, when R4 is advertising its prefix 4.4.4.4, R6 will be receiving that and he will be advertising that to R1, but this time R1 is not going to update that to R2 because of the split horizon rule. So R2 doesn't know how to reach 4.4.4.4. He will not be receiving that routes. Let's go and verify. So from R6, show IP BGP. Do I receive anything which is 5.5.5? No, right? We are only receiving 4.4.4 on R6. And let's see on R2 whether which routes that we are seeing. So in R2, show IP BGP. I'm seeing only 5 which is coming from router 5, but I'm not seeing 4.4.4. But what about R1 and R7? Okay, R1 and R7 will receive both. Okay, when I say show IP BGP, it is having both 4 and 5, but still it is not the best path, but it is a valid path because of the next stop issues. Let me just quickly go and fix that, because we know how to fix the next stop issue with the BGP. This is what that we have done in our previous troubleshooting lab. So just we have to go and enable next stop self here and here, and also from R6 to this neighbor and to this neighbor. Okay, so in R2, let's go and enable that. Configure terminal, router BGP 500, neighbor 1.1.1.1, next hop self. If you don't know what I'm doing here, just go and watch the previous troubleshooting video where I have explained this, why I'm doing this command. Okay, and also I have to mention 7.7.7 next hop self. Okay, so router 2 is done. Let me do the same for router 6. Configure terminal, router BGP 500 neighbor 1.1.1.1, next hop self, and also neighbor 7.7.7.7 next hop self. That's it. Okay, let's go and verify now. Okay, so for time being, what you understand here is like, okay, this is not a best path, this is not the valid path. It is a valid path, but not the best path, so it will not get installed in the routing table. So obviously BGP is not going to advertise to the other peer. Okay, but now if I clear the BGP process, clear IP BGP start soft, and see, I'll be receiving. See, it is valid and also best. That means I'll be seeing that in my routing table as well, right? I'm seeing R1 routing table. I am seeing 4.4.4 and 5.5.5 in R1's routing table. Now it is good for R1 to advertise to R2, right? And vice versa. Okay, but it will not happen, even though it will not happen. Why? Because if you go to R2 and just see show iBGP summary, still you're not receiving any prefixes from R1 and R7. The problem here is split horizon is stopping R1 and also R7 from being advertised the network whatever R6 has advertised to them to R2. This is not allowed, and also vice versa. So if we want to make this work, what we have to do? Okay, so there are two solutions. One, you can do route reflector, route reflector or configuration. These are the two solutions that you can implement to avoid to overcome this issue. Okay, that means what you're going to do is like you are going to make R1 as a route reflector server so that R2 and R6 will act like a route reflector client. Okay, okay, why I have to do in this way? Why I am making R1 as a route reflector server? Because R1 is receiving the routes from R2 as well as R6. Okay, whichever received from R2 will not be advertised to R6, and whichever is being received from R6 is not advertised to R2. When I make this as a route reflector server, now as a server, R1 can advertise the routes whichever is learning from R6, and also R1 can advertise the routes whichever learn from R2 to R6. So there is no restriction now. Okay. Similarly, I have to enable R7 as a route reflector server, and I have to make R6 and R2 as a route reflector client. Okay, so similarly how we are doing it in R1, the same way we will be doing it for R7 as well. Okay, let's go and see the configuration. So in R1, router BGP 500 and the neighbor. Before doing this, let's just verify. Okay, there is a command to verify which are the prefixes that I'm advertising to my neighbor. So let's verify from R5 because he's advertising some prefixes to R2, right? So go to router 5 and type show IP BGP and type the BGP neighbor IP is 25.0.0.2, and then you have to type 0.0.2. Okay, you have to give the neighbor and the neighbor IP and then advertised routes. If you type this command, you will see what are the prefixes that you are advertising to this particular neighbor. All right. Similarly, if you go to R2, and see show IP BGP neighbor 1.1.1.1 and advertised routes. If you hit, you will come to know what are the prefixes that you are advertising to R2. Okay, now R2 is advertising to R1 the prefix 5.5.5.5. But if you go to R1 and see, before doing this config, do show IP BGP neighbor 2.2.2.2 advertised routes. You are not advertising anything from R1 to R2, but also for R6 as well. Let's verify the same. Advertised routes. See, zero prefixes, right? If you go and see in R7, you will be getting the same result as like R1. So we'll check the same once we done with the Route-Reflector config. So go to neighbor. Here there is no separate command that to define R1 as a Route-Reflector server. Only just will be going to R1 and just we say who those okay only just we will be saying R2 and R6 are your Route-Reflector clients. That's it. Okay, so neighbor 2.2.2.2, he is a Route-Reflector client. Okay, that's it. This command will act like as we discussed. Now neighbor 6.6.6.6 Route-Reflector client. Once you do this, your neighborship will be going down and then coming up. Okay, so previously I have checked what are the prefixes that I'm advertising to my neighbor 2 and neighbor 6. Previously it was 0. Let me check the same now. Show IPBGP neighbor 2.2.2.2 and then advertised routes. Now I'm advertising two routes 4.4.4 and 5.5.5, right? And what about for router 6? 6.6.6.6. Same, right? So this fixed that split horizon issue in our iBGP environment. So similarly, you can go and implement the same for router 7. Okay, router BGP 500 and the neighbor 2.2.2.2 Route-Reflector client and neighbor 6.6.6.6 Route-Reflector client, and we are done. Okay, in R5 when we have checked show IP BGP here, sorry, previously no, in R4 I think. Okay, we haven't verified that, but here in R4 we are seeing it is just one prefix that it was learning. Okay, fine, no problem, don't get confused. Okay, now let's check show IPBGP. Now I'm receiving 4.4.4, which I was not previously receiving it, right? Now if I ping, I can ping 4.4.4.4 source loopback 0. See? So today what we have learned in this video is about a Route-Reflector client. Okay, Route-Reflector. We'll be seeing about the configuration, how to do that configuration in our next video. So for time